Hello there. Here are a few more worked examples on geometric sequences. This is similar to one we've done before, but there's something you've got to be a bit careful of, and you'll see why in a minute. If the following three terms form a geometric sequence, find the value of x, hence find the rule for the geometric sequence. So it goes like this, as you can see. 1/9, the next term is x, and the third term is 1 over 81. Okay, let's have a go at this. So the thing about geometric sequences is that they have a common ratio, and what that means is that the second term divided by the first term must equal the third term divided by the second term. Okay, and that's the fact about geometric sequences we're going to make use of here. So let's just write that down. That the second term divided by the first term must equal the third term divided by the second term. Okay, now here we need to recall a bit about fractions and how they work, but in a nutshell, in this case, if you divide anything by a ninth, it's the same as multiplying that thing by 9, isn't it? So we can say on the left hand side that 9x is equal to, now here's another thing about fractions, this sort of fraction we can drop the 81 down there, or more like that really, but I'll let you play with fractions a bit more later, but for the moment that's what we can do here, and that's going to speed things up. Anyway, so 9x must equal 1 over 81x, like so. Now there's a couple of ways of solving for x from here, but probably what would make most sense is to multiply both sides by 81x. That'll get rid of that, and we can do that as long as we multiply that by 81x. And when you do that, you're going to find, that 729x squared is equal to 1. Then we'd simply divide both sides by 729, like so. And then we're going to take the square root of both sides. But what you've got to be careful of is this, that when you take the square root of both sides, there's a positive and negative possibility. And yeah, you've just got to be careful about that when you take the square roots. So what we're saying, therefore, is that x could equal either positive or negative. The square root of 1 over 729 simplifies to this. Okay, so the second term in our series, back here, could equal either 1 over 27 or negative 1 over 27. Now we had to find the rule for the geometric sequence, and that's a little more complicated in this case, isn't it? Because we've got two possibilities for the second term, positive 1 over 27 or negative 1 on 27. Not to worry, let's just do it. So in the first case, it's quite clear that a is equal to 1/9, the first term, and that'll be the same over here, of course. But what's different, of course, is the common ratio. So in this case, on the left-hand side, the common ratio is 1 over 27 divided by 1 on 9. Now, when you flip your, because what we're doing here is we're dividing one fraction by another fraction, you invert the second one, that one, and invert means tip it over, find the reciprocal of or whatever, and change this divide to a times. And what you're going to find is that it comes to 1/3. And of course that makes perfect sense, doesn't it? Because 1/9 times a third is going to give you 1 over 27. Now over here, there's not much difference really. So the common ratio is the second term divided by the first term. And the only thing that's different from the left-hand side over here is that you've got a negative instead of a positive. So r is simply, in this case, negative 1/3. So we've got two possible rules that could have been applied to our original question. Over here on the left-hand side, we can say the rule is, now remember it's a times r to the power of negative to the power of n minus 1, and so in this case that goes like that. A is 1/9, R is a third, and it's to the power of n minus 1. And over in the right hand side, very similar of course, but instead of R equaling 1/3, over here it's going to equal negative 1/3 to the power of n minus 1. And that's that problem done. Okay, another problem. We've got a little sequence going here, a geometric sequence we're told, and our job is to find values for x and y. Okay, so we make use of the common ratio idea. In other words, that divided by that must equal that divided by that, which must in turn equal that divided by that. So 6 divided by x must equal 8 divided by 6. And our job is to solve for x, of course, so what we can do is multiply both sides by x, that's why we get 8x there, and multiply both sides by 6, so 6 times 36 is 36. So x equals 36 on 8, and that can be simplified. The highest common factor for 36 and 8 is 4, so 36 divided by 4 is 9, 8 divided by 4 is 2 of course, and if you prefer you can say that x is equal to 4.5. Okay, something similar for the value of y. We're going to say that 8 over 6 is equal to y divided by 8. Y divided by 8. So cross multiplying again, we get 64 equals 6 times y, which is 6y. Therefore, dividing both sides by 6, we discover that y is equal to 64 on 6. 2 is the common factor for 64 and 6, so y is equal to 32 on 3. And if you prefer, you can say y equals 10 and 2/3. Our rule would be like this. Tn equals, I said the first term was 4.5, didn't I? So we might call it 4.5 for the purposes of this. And we said the common ratio was 4 on 3. And you just raise that to the power of n minus 1. And now that we've got that rule, we could find any other term in that sequence. So we can go ahead and find the rule for that sequence. We know the value of a, which is just the first term, of course, is 4.5, and we discovered that the common ratio was 8 on 6, but that can be simplified to 4 on 3. So substituting that information, a value for a and a value for r, into our general template, that's the rule we come up with. What you should do now is probably check that the value for y was correct. And the way to do that is to let n equal 4, because y was the fourth term. And you should find that it equals what we found before. Okay, I suggest you press pause and read this question, and press play again when you're ready to hear my explanation of how to go about it. Okay, so here's the way I think about it at any rate. The fourth term, we're told, is equal to -1. And we're going to have the fifth term, the sixth term, seventh term. We don't know any of these yet, of course. The eighth term. We do know the ninth term because it's given in the question, and it's 32 on 2, 4, 3. Now ask yourself this question: how do we get from -1 to the next term, to T5? Well, you get there by multiplying -1 by the common ratio, don't you? And then, oops, that should be a time sign there. And to get to the next term, you're going to multiply the fifth term by r again, which is r squared, and so on and so forth. So you're going to multiply this one by r cubed, and r to the power of 4 for the eighth term, and that's going to equal -1 times r to the power of 5. Okay, now that's all very well for this problem, but if you're trying to find the common ratio for where there's a big gap in the number of terms, you're going to be in a bit of shtuck. But fortunately, there's a bit of a pattern here. What is 9 times 4? Take 4. Well, of course, it is 5. And you're going to find that applies in all these sort of problems. Okay, so in other words, what we can claim from that is this rather simple fact, that -1 times r to the power of 5 is equal to the ninth term, isn't it? So that's 32 on 243. Alrighty, now what I can do at this stage is divide both sides by -1 or times by -1, doesn't matter, has the same effect. And we find that r to the power of 5 is equal to -32 on 243. So to find r, all we've got to do is take the fifth root of both sides. So r is equal to the fifth root of -32 is -2. Ask your calculator if you don't trust me, but -2 raised to the power of 5 is definitely -32. And the fifth root of 243 is 3. Okay, so r equals -2/3. Now remember before we were talking about taking the square root of both sides, and there are positive and negative possibilities. That's true for even powers, so if you're taking the fourth root of something, you've got to be a bit cautious. There's a positive and negative result. But for odd powers, if the fifth root of, you don't have to worry about the positive and negative when taking the root of an odd power. Okay? Alright, so we know what r is. Our next job apparently is to find a, and then we're going to find the rule for the sequence. Right, to find the value of a, we're going to apply the sort of same logic we used before. We know the fourth term was, was given in the question as -1. And so to find the third term, we'd simply divide by the common ratio, isn't it? So, and then to get to the second term, we'd divide by -1 on r squared. So, and to get to the first term, it would be -1 divided by r cubed. Now, remember what r was? It was equal to -2/3. So r cubed is simply -2 cubed over 3 cubed. So that's equal to -8 on 27. So a, as we've the first term, is equal to -1 on r cubed. That's r cubed there. I should say that, shouldn't I? R cubed equals -8 on 27. So a is equal to -1 on -8 on 27. Now when you're dividing 1, I know this is -1, but when you're dividing 1 by a fraction, all you've got to do is tip over that fraction and you've got your answer. So, and by the way, the negatives here will cancel each other out, won't they? You've got a negative divided by a negative, so it's going to be positive. So tipping over -8 on 27, it turns out that a, the first term, is 27 on 8. Now that will enable us to find the rule for the sequence, because we've got a, we've got r, that's hiding somewhere, there it is there, and we can simply substitute those values in to find the rule for the sequence. So what we have is that a equals 27 on 8, and r equals -2/3, and because we're finding a rule for a geometric sequence, it must follow that pattern. We can say the rule for this sequence is 27 on 8 times -2/3 to the power of n minus 1. And that's pretty well it. I mean, sure, there are things you can do in terms of simplifying this, because that's a power of 3, that's a power of 3, and you've got 2's going on there. But we will just leave it like that for the moment.